While I attended multiple lectures throughout the year, the lecture of the Physics of Breakfast by Peter Yunker was by far the most captivating to me. Yunker took an interesting approach to his lecture. He used 3 examples of different but common breakfast essentials and explained the physics behind them. His goal was simple: to prove that physics is everywhere and actually really interesting. As a physics student, I enjoyed his lecture much more than others because he gave me real-life examples that I could see occurring with my own eyes, in contrast to usual abstract theories learned in class. He also taught us that while the physics of breakfast food sounded silly and irrelevant, the physics principles behind the phenomenons led to serious medical breakthroughs, like inexpensive and in-the-field Alzheimer's and malaria tests. To effectively convey his points, Yunker used 3 different examples and explained the commonly recognized but rarely understood phenomenons. 3 of them that he explained is the coffee ring effect, scrambled eggs, and the clumping of Cheerios in your cereal. The most interesting phenomena of the 3 to me is the coffee ring effect. While seen very commonly, especially in a place like Georgia Tech, few ever really understand why when coffee evaporated, it left a ring shape instead of a uniform circle shape. Yunker taught us that it begins with what coffee really is. Coffee is hot water with extracts of oils and small molecules from the coffee beans suspended in it. What we can take away from this fact is that the coffee ring effect will happen with any liquid with molecules suspended in it. Using micro-sized plastic spheres in water under a microscope to prove the theory, the plastic spheres were small enough to follow the natural flow of the water to the outside of the edges to adhere to the theory of adhesion. Yunker describes such a complicated theory very easily in the way of describing that the water molecules have to adhere to adhesion and cohesion due to their characteristics, thus forming the spherical cap shape. As the drop evaporates, the dropped edges are penned in place and the molecules evaporate from the center rather than the edges, which minimizes surface area. Since the drop edges are penned, the fluids are pushed from the center to the edge, carrying the suspension of the dissolved molecules with them. Yunker aptly called this phenomena a happy accident. After explaining the difficult concept of the coffee ring effect, Yunker then moves on to a concept that only shares the common characteristic of being related to breakfast food. In addition to teaching us the physics behind scrambled eggs, Yunker also taught us the importance of testing your assumptions to make sure they are accurate. He showed this by explaining how he first tested the assumption that raw eggs were a liquid and cooked eggs were a solid, using the creep test. Then he posed a question to us: why, when water is heated, it turns from a liquid to a gas, but when raw eggs are heated, it turns from a liquid to a solid? As no surprise, no one even had a clue how to begin to answer such a question. Like coffee, raw eggs are a suspended liquid, but with proteins instead of oils. Each protein has hydrophilic and hydrophobic qualities to it, and would fold themselves in such ways to accommodate these preferences with the surrounding water molecules, with hydrophobic regions on the inside of the folded protein and hydrophilic molecules on the outside. As the raw eggs were heated, the proteins would denature and unfold, attracting hydrophilic and hydrophobic regions of the other proteins, leaving an elastic gel of proteins. He also made sure to note that salt or anything acidic would denature the proteins as well, as used for hard-boiled eggs. A final concept that Yunker explained is one that most cereal enthusiasts already know: that the Cheerios in your bowl of cereal often clump together. This is because the adhesion of Cheerios, which are less dense than milk, creates a meniscus. The Cheerios climb up each other's meniscus to reach the highest point, deforming the surface of milk in the process, thus attracting each other in clumps. Even objects like paper clips, which are denser than milk, exhibit the same tendencies due to surface tension. Through these explanations of these fascinating concepts, Yunker did a fabulous job at showing that physics can be interesting and applicable in everyday life and can be found and applied almost anywhere, even in breakfast food. As Yunker sparked my interest in the examples of physics around us, I found myself explaining these concepts to my friends and family, sparking their interest as well.